All right. Good afternoon, and thank you for joining us for our first Lunch and Learn of the 2024 season. Welcome to A Billion Years of Interstate State Park. My name is Tanner Stoffren, and I am the Marketing and Communications Coordinator at Wild Rivers Conservancy. We are the official nonprofit partner of the St. Croix National Scenic Riverway, and it is our job and duty and mission to inspire stewardship and to forever ensure the rare ecological integrity of the St. Croix and Namakagon Riverway. As a nonprofit, we depend on the support of individuals and businesses throughout the watershed to carry out our important mission. If you are inspired by our work and learning today, please consider becoming a donor, volunteering with us, or participating in one of our many upcoming events this summer. And for those of you who are already supporters of Wild Rivers Conservancy, we thank you for your support. Before we begin, quick couple of housekeeping notes. Please remain muted and your camera off. There will be opportunity to submit questions via the chat function, and time for our host and presenter Jenni to get to them at the end of our session. This is recorded and will be published live on our YouTube channel in the following week. So for those of you who have to leave early or miss something, there will be opportunity to continue your learning online there. And with that, it is my honor to introduce our speaker and presenter today. Jenni Webster joins us from Minnesota Interstate Park, where she is an interpretive naturalist. She has the privilege of connecting visitors to the landscape of Interstate Park for over 13 years. She has thoroughly enjoyed sharing the story and the place that is shaped through geology. Jenni holds a Master of Science degree in Environmental Education and Interpretation from UW-Stevens Point, where I happen to go to school. Great college. And she has worked for a variety of parks and nature centers. So with that, I will turn it over to Jenni.
Sounds good. Thank you so much, the Wild Rivers Conservancy, for the opportunity to share some of the park's story with you today. I'm going to go ahead and get my PowerPoint going for us here. I've had the privilege of working at one of Minnesota's over 70 state parks and recreation areas for over 13 years. And I do have to be candid. My training is as a biologist and as an interpretive naturalist or educator, not as a geologist. But I've been lucky enough through this job that I've had the opportunity to learn from past staff, from geologists that have come to bring their classes there or to lead programs for the park, through exploring on my own and through reading new research that's coming out. And so I'm packaging all of those things together into kind of a virtual tour of the state park where I work. And to get things started together today, what I'd like to have you do for just a moment is to imagine something for me. I want you to imagine the last natural landscape that you went to that kind of took your breath away. Maybe it inspired some curiosity in you, maybe a sense of wonder. Maybe it even made you feel kind of small. Was that place nearby or was it far away? Was there something in particular there that really stood out to you and left a lasting impression? There are so many places that stay with us long after our visits there. And sometimes getting to know the story of those places makes our visits there so much more meaningful and impactful. Now, for me, one of those places that sticks with me is the place that I work, Interstate State Park. And its scenery is amazing, but so is its story. And that's what we get to explore together today. So take just a moment. Let your eyes look over the image of this spot at Interstate State Park in Taylors Falls, Minnesota, next to the St. Croix River, and think about what stands out to you in the landscape here. Is anything catching your eye? What if we move a little further up the trail? Is there anything that's standing out to you here? Well, for hundreds of thousands of people that visit the park every year, It's the rock that stands out for a lot of them. The geology of this site and the rock that people are sort of in awe of here is so important that we actually lead lots of guided geology tours for visitors through the summer and the fall months here because we want to share that story. It's a pretty impressive one. And as we explore that story today, let's go ahead and take a closer look at the rock. We've got a beautiful outcrop of this dark gray basalt rock in front of us here. And that's where our story is going to begin. You could look at this and just say, no, it's just a dark gray rock. And this type of rock is actually pretty common across planet Earth. But to find it in the middle of a continent is a little bit surprising. And that's because this dark gray basalt rock began as molten hot lava. Now, when I say that word lava, I'm guessing that for most of you, the state of Minnesota or Wisconsin is not the first one that comes to mind. Maybe you're thinking of Hawaii. Maybe you're thinking of a place like Iceland. And while these places do have basalt, we've got amazing lava flows that happen right here in Minnesota. Lava flows that eventually cooled and hardened into that dark gray basalt rock. The area was once covered by these lava flows. So where did they come from? Well, 1.1 million years ago, 1.1 billion, excuse me, even further back in time, 1.1 billion years ago, the Earth's crust in this area was being pulled in opposite directions. So imagine that Minnesota and Wisconsin were actually being pulled away from one another, and the Earth's crust was thinning and stretching to the point that it tore, it split. And out of these huge splits or cracks in the Earth's crust, an incredible amount of lava was able to escape and ooze out across the landscape. Now, the lava that was coming out here was fairly thin, so it kind of oozed out across the landscape almost like pancake batter. In fact, in some areas, it flowed almost a mile away from its source. And lava was pouring out of these cracks for millions of years. The lava would flow out, cool and harden and become a layer of basalt, and then more lava would come out and stack on top again of that basalt. And this would happen again and again and again until you had these stacked lava flows in the area. Today, if you come to the park, you can see 10 of these lava flows, but there were likely many more a billion years ago. These lava flows left behind much of the landscape that we see in the park today, but they're part of a much larger story that nearly split what's now North America in half. So let's take a closer look. I've got a map of the Midwest in front of me. And this basalt rock can be found from Kansas up through where we are, beneath where Lake Superior sits today, and all the way down into Michigan in a giant, almost 2,000-mile long arc across the Midwest. This is all an area where lava was flowing out of these cracks in the Earth's crust. Now, the most recent theory about why the Earth's crust was being pulled and torn in this area, called the mid-continent rift, is that there were two land masses moving away from one another. So one of them was the Laurentia Craton. So imagine a big mass of land that's the sort of the core of what's now North America. And another big land mass, the Amazonia Craton. And that's sort of the core of what's now South America. They were being pulled away from one another, splitting. And as that happened, geologists are thinking that that was putting pressure on the middle of that land mass. And so we had rifting happening here in the area that's now the Midwest. When that splitting stopped, it relieved the pressure and the splitting or tearing in the mid-continent rift stopped. Now, this is a fairly new theory. It's something that geologists are still collecting more information on, and I'm excited to find out more about what they learn about this mid-continent rift. So imagine over a stretch of almost 2,000 miles that we have lava flows escaping from beneath the Earth's crust, pooling over land, and then cooling and hardening on its surface. So much lava came out of the mid-continent rift that it could have filled about 123 Lake Superiors. In some places, the lava flows that were stacked on top of each other were miles thick. And when this rifting finally stopped, it left a thick, dense scar of this basalt over the landscape. Basalt is heavy and dense igneous rock, and in places, it actually sagged underneath its own weight. We see in the middle of this drawing here, that spot in green where the basalt rock is sort of sagging down into the crust. It's that heavy. The rock is also dense enough that it creates some gravity anomalies locally. Let's take a look at a map of that. Do you remember the map I showed you of where the mid-continent rift stretches, where you can find that basalt rock? Well, sort of paired up with the map in front of us from USGS here. And can you quickly find where the mid-continent rift stretches on this map? This is actually a map of gravitational force, and we're seeing in the light pink where the mid-continent rift ran and later filled in with that dense basalt rock, that there is what's called the mid-continent gravity high happening there. There's actually a little bit more gravity working on me here in Taylor's Falls than there would be if I stepped away from this area of dense basalt. So it means that I weigh maybe a half an ounce more here than I would if I stepped away from the dense basalt rock, maybe into western Wisconsin. The lava flows from this mid-continent rift that almost split North America in half left their mark on what's now North America, but it definitely shaped the landscape that we see at the park today. And if you look closely at the basalt rock here at the park, you'll find all kinds of interesting clues that hint at its start as lava. Take a look at the photo in front of you here, and what stands out about this area of basalt rock to you? Did the cracks in the rock catch your eye? These cracks are pretty common in basalt rock, and they form as the lava is cooling and contracting and turning into basalt. They start off very, very small, and as the rock has been here for millions of years, they've gotten bigger and bigger and bigger. In other areas of the basalt in the park, you notice some unique textures. Do these little teeny tiny holes stand out for you here in the rock? They're a clue that the rock began as liquid rock, as lava a billion years ago. You're seeing what remains of ancient gas bubbles that were moving through these lava flows and then were trapped at the surface where the lava cooled and hardened fastest. Those gas bubbles, or vesicles, can actually tell you where you are in one of the lava flows at the park. Take a moment to look at the photo, and with your eyes, can you find where those vesicles or gas bubbles are most concentrated? Your eye might be moving more up towards the top of this rock wall. This is towards the top of one of those ancient lava flows. The gas bubbles would rise up, just like they do when we open a can of pop, but they get trapped there as the lava cools and hardens. And as your eye moves down this wall, we're moving into the middle of the lava flow, and there are fewer of those gas bubbles or vesicles remaining. In some places, as you explore the basalt at the park, you might find spots where these gas bubbles have later filled in with minerals. Water has moved through there and left minerals behind, often quartz. And we call these little filled in spaces amygdales. And you're seeing some of those in the photo to the right. Now, amidules are what we have in this area of the basalt that was left behind by the mid-continent rift. But if you were to go further north towards Lake Superior and look at the basalt there, you might find some more complex features that filled in these empty spaces in the basalt rock. You might find things like Lake Superior agates. And this is where water's moved through the rock and it's left behind quartz and other minerals, sometimes staining them red with iron and creating these beautiful, colorful agates that we're seeing here. These are just a few of the clues that were left behind in the basalt rock that tells that story of the mid-continent rift and the lava flows that were here a billion years ago. But that certainly isn't the only story that shaped the landscape that we see at the park today. So we're going to close the chapter on lava flows cooling and hardening into basalt rock a billion years ago. And we're going to fast forward in time together. We're going to imagine that millions of years have passed and the core of what's now the North American continent has changed and moved. It's kind of turned a bit and it's started to make its way closer to the equator. Things are going to start to feel sort of warm and tropical in our next move. We're going to fast forward to 550 million years ago when the landscape at Interstate State Park would have looked much more like this. We were at the edge of a shallow sea that covered most of what's now the Midwest. That shallow sea was a little shallower as you went to the north and east, and as you went south and west in Minnesota, it got a little bit deeper. Beneath the waters of that sea, as sand and other sediments were pressed together, they formed different types of sedimentary rock. Where the sea was deeper, we find things like shale and limestone. Where it was a little shallower, like where we are, you would find things like sandstone. There were places in this sea where there were tall outcrops of basalt rock that would have stuck out just kind of beyond the water, sort of like in our image here. The sea covered the area, some of these outcrops stuck out, and much of the basalt didn't. Much of the basalt was actually covered by layers of the forming sandstone. It was buried here. So if you come to the park today, you can see some really lovely evidence of what had formed below the waters of that sea. You find layers of this sandstone, tall outcrops of it. And this was all formed at the bottom of that Cambrian Sea. Grains of sand were cemented and compacted together beneath the waters of that sea. If you've ever taken Highway 8 into the town of Taylor's Falls, you've maybe noticed big sandstone outcrops in the distance where the road cut is made. Get a little closer look at some of those layers. This would have been on top of the already existing basalt. If you hike one of the park trails like the Sandstone Bluffs or Railroad Trail, you can get a really close look at this. And it has beautiful colors, some of them from minerals moving after the sandstone has formed. If you look in places, you might even see some places where the sandstone was forming at different angles as that sea was sort of shifting where it was moving the sediment and the sandstone was forming. Remember, we were at the edge of the sea, and that's kind of a dynamic place. There's a lot of movement that's happening there. And some of that movement created another feature that draws many geology students every year. So I want you to imagine this. That Cambrian Sea is covering much of the area. We're at kind of the shallow shoreline of it. And there's outcrops of basalt rock that are sticking out of the water. The waves and the sea are crashing and slamming against these rock outcrops to the point that they're loosening boulders and big chunks of the basalt rock. Those tumble down, splash into the water, and roll beneath the water. They're trapped there as sandstone slowly starts to form around it. And that creates a feature at the park that you can see today called the Mill Street conglomerate. If you look closely here, you'll notice a few areas that are darker gray. That's the basalt. And then you might see some areas that are more of a tan color. That's the sandstone matrix that kind of filled in around the boulders that had fallen. So let's get a closer look at that. Now you might be able to even better see those gray boulders that were trapped in the forming sandstone. And that created our Mill Street conglomerate here at the park. Sort of a unique feature that you don't see in a lot of other places. This would have been just sort of towards the edge of the sea where the boulders had rolled off of the outcrops and then gotten stuck in the forming sandstone. When we talk about sandstone, it often sparks questions about fossils for people. Now, fossil collecting is not legal in the state parks for good reason, but the rock that we have here is not really the best for finding fossils, and that's because of where we're located in that shallow sea. We were sort of at the edge, right? That's the most dynamic, kind of volatile area, and the sediments there were probably moved around and unsettled quite a few times. So that didn't make great conditions for fossils to be found. Occasionally, a geologist will spot part of a trilobite or a brachiopod, but often they're in sort of what they call a fossil hash. It's more bits and pieces that have been broken apart by the wave action before the fossils were formed. So we have this beautiful sandstone left behind the park that tells the story of an ancient sea that was here and then went away. We're going to keep moving forward in time again. We'll imagine that millions of years have once again passed. They're a little bit of a blank chapter in geology, much of which was erased by the events that are going to come next. So imagine again what's now North America is changing and shifting and sort of moving once again. And we move away from warm tropical temperatures into something that's quite the opposite. We enter ice ages here in Minnesota. The climate has cooled and the snow doesn't melt. It starts to stack and pile up on top of itself to the point that it presses into thick sheets of ice called glaciers. And these glaciers are maybe 4 times taller than the tallest buildings in the Twin Cities. They're immense sheets of ice. Now, the snow is piled up, the ice is formed so thickly that it's incredibly heavy. And so the weight of that is adding pressure to the ice at the bottom, and that allows the glacier to sort of flow or slowly move across the landscape. These glaciers are wearing away hills. They're freezing onto boulders and picking them up and dragging them for miles. They're picking up soil and moving it. They're gouging out deep, broad valleys. And in Minnesota and Wisconsin, a lot of the landscape that we see out our window as we're traveling by is the result of the glaciers. We see kettles and drumlins and moraines. Well, these glaciers came and went over parts of the state for over 1 million years. But the Wisconsin glaciation is what left most of the evidence that we see around us today. And that spanned from about 35,000 years ago to just about 10,000 years ago. And while evidence of what the glaciers did during that time can be found in many places in Minnesota and Wisconsin, it didn't leave behind much evidence that we can see today in the park. One of the clues that we can find is on hilltops, kind of above where the sandstone outcrops are, where we find layers of sediment that would have been moved and left behind by glaciers that were moving into the state from different areas. They left behind the sediment. They probably left behind a lot more evidence, but that evidence is sort of erased by what happens when those glaciers melt and recede out of the area. So let's take a closer look at what happens then. The glaciers have left Minnesota, but they can still be found in a lobe of ice up towards Canada, just kind of at the eastern edge of where Lake Superior is today. That's the Superior Lobe, that block of ice that's blocking the eastern edge. And a little over 10,000 years ago, glacial Lake Duluth is sitting in that spot. And it's sitting in basically a bowl of sagged rock, perfect depression for water to collect in. Water from the melting glaciers is pooling there, and it can't get out to the east. So it just keeps pooling up and pooling up until finally it's 400 or 500 feet higher than where Lake Superior is today. So imagine that amount of water. And it overflows. It starts to create a path to the south to release that water, and it makes its way down where the Brule River is today and down into where the St. Croix River flows today. Now, its path changed slightly over time, but we're going to focus on the route that we see today. This is our evidence that glacial Lake Duluth drained and added water that flooded through this area 10,000 years ago. Imagine most of the rocky areas that you're seeing to the left and right in this photo would have been covered by the water from that larger river. We'll call that the glacial St. Croix River. It was about a mile wide and it was moving incredibly fast. As the river is carving out this river valley, it's carving into the softer sandstone. It's eroding away some of the basalt rock. And it does something a little bit unusual. Take a peek here at the St. Croix River as it flows below the Highway 8 bridge from Taylor's Falls into St. Croix Falls, and then takes this strange, sharp 90-degree turn. Now, it's a little unusual for a river to take such a sharp turn. They usually like to go straight if they can. But we think that what the river encountered here was an area where the basalt rock was more brittle. It had been more fractured, likely because it was very close to that ancient fault or rift that the lava came out of over 1 billion years ago. So this rock is a little easier to erode or wear through, and the water changes its course. It makes its way through the path of least resistance, where the rock is easier to wear through. And that's the channel that our St. Croix River takes today. Here's an image of flooding happening on the St. Croix River in recent time. But imagine this water covering most of the rock that we can see in the photo 10,000 years ago. And then imagine it moving as quickly as water shooting out of a fireman's hose in places. And the park is located on the inside curve or bend of the river, so the water's moving incredibly quickly there. And the sound of the water at that time would have been overpowering. The water is crashing into the basalt rock. It's wearing it away, but it's also bashing into it to the point that some of the water hits the rock and then starts to spin in giant eddies or whirlpools. These spinning whirlpools are picking up sand and gravel from the river, and it starts to spin it around and around, creating a liquid drill. A liquid drill so powerful that it can wear away the basalt rock deeply, leaving behind these big holes, these glacial potholes. Now, if you and I wanted to make a hole in the basalt rock, we would need not only a very expensive drill bit, like a diamond drill bit, we would also need a lot of time. Basalt is really hard stuff, but the power of that glacial St. Croix River, the sheer volume of water coming through it and how quickly it was moving, made it possible for it to wear huge features into this hard rock. If you look at the image of this glacial pothole on the screen, do you see a little bit of a spiral or a corkscrew shape on it? I really love how that helps me imagine the path that that spinning water was taking. Now, potholes weren't the only thing that were created when those whirlpools were moving in the glacial St. Croix River. Anything that was picked up by the river, like large chunks of rock, would be spun and polished in that swirling sand and water until it was like it was inside of a giant rock tumbler. And that left behind inside the potholes things like smooth, round rocks that we call grindstones. They almost look like eggs, they're so smooth and polished. The water also was able to pick up and move large chunks of rock, boulders that weigh several hundred pounds. And it was actually able to smooth and polish some of those. The top of this photo, we're seeing a good example of that. Now, the water in the glacial St. Croix River doesn't last for forever. Tens of years, hundreds of years, and then eventually that eastern edge of what's now Lake Superior that was blocked by that lobe of ice has a path that it can take again. The ice melts there, and glacial Lake Duluth is draining in another direction. And that means that cuts off the immense flow of water that was once forming the glacial St. Croix River. That river gets smaller and smaller and smaller until it's just the size of our St. Croix River today. But it leaves behind all sorts of these glacial potholes where the riverbed used to be. Some of them are just a couple inches deep, like this little one here. Some of them are 6 or 7 feet deep, like the ones we're seeing here. One of them is the deepest explored pothole in the entire world, called the Bottomless Pit. And this pothole was given this ominous name because it was so difficult for park workers to get to the bottom of. This park was started in 1895 to protect these unique features, and some of the early park workers had the privilege of being asked when they came to work to clear out organic matter that had been sitting in these potholes for thousands of years. So can you imagine being asked when you come to work to get into one of these with buckets and shovels and just keep digging until you find the bottom? Well, it took several tries on this deeper pothole, such a challenge that they called it the Bottomless Pit. Eventually, crews did find the solid bottom of this pothole at 60 feet deep, and that makes it the world's deepest complete explored pothole right here in Taylor's Falls. If you look closely at the sides of this pothole, do you again see a little bit of that spiral or corkscrew shape on there? Really helps me picture how the water would have been moving as it was carving into the basalt rock all those years ago. When park workers were clearing these potholes out, they found hundreds of those smooth, round grindstones, and they found lots of sand and sediment that had been left behind by the glacial St. Croix River. Now, sometimes whirlpools would form near each other and they would carve out individual potholes, but then as the whirlpools were moving again and again and again, they would start to wear away the basalt rock between them. And that would open up large, almost like corridors in the basalt rock. We're seeing one here where if you look closely, you might notice some kind of smooth, polished edges here and there. If you move your eyes to the right of the photo, you might even see some gentle sort of half circles carved into the rock. This area used to be separate potholes that merged together as the water continued to erode the rock. Now, if you were to visit the park and you had 2 summers, because this is how long it took our intern to do this a few years ago, you could find all 426 glacial potholes within the state park. You find potholes in other parts of the world, in other parts of the US, and even in other parts of Minnesota, along the Kettle River, Minnesota River, up north by Temperance and Chattahoochee State Parks. But to find so many potholes and to find ones that are so large in such a concentrated area really is unique. And we notice, when we go back to this map of the glacial potholes, that some of our deepest potholes, these big orange circles, run parallel to where the St. Croix River turned. Maybe parallel to some of the jointing, that sort of brittle, more fractured rock that was happening here. And perhaps there was a little bit of that happening in this area as well. We know that this glacial St. Croix River happened here because it carved out this huge channel. It carved out these beautiful basalt cliffs that we see in the park today. And it also left behind the glacial potholes that many people come every year to see and enjoy. We're seeing an example of one of those glacial potholes in our image here, but I challenge you to look at the photo more closely and see if you can spot a clue about the earlier history of this rock when it started as billion-year-old lava. Does anybody see the little gas bubbles or vesicles in the lower right corner? What I think is so amazing about this park is you have all these different layers of geologic history that are sort of touching one another in a small area. And it allows you to really explore a story that spans a billion years, but you can travel and explore in a few hundred yards at the park. In our time together today, we moved through a huge span of time together here at the park. And I challenge you to think for just a moment about these stories. Were any of these familiar to you? Had you heard them in relation to where you live, to places that you visited before? Were any of these stories a surprise or something new that you didn't know about? They were new to you. I hope you enjoyed exploring some of these stories that are layered and stacked up here at Interstate State Park. And I encourage you to keep exploring stories like this all around you where you live or where you visit. The geologic world is really full of awe-inspiring tales, and knowing these stories can really enrich our experience in these places. It can turn what might look like a common gray rock into ancient lava. It can turn a piece of sort of tan, grainy stone into something left behind from a tropical seabed. And that's one of the reasons that I really love geology and exploring stories like this. And I invite you to come out to Interstate State Park and explore some of these stories for yourself. If you come out to the park, you can see examples of that lava-formed basalt rock just kind of south of downtown Taylor's Falls. This is also the area where all those big glacial potholes can be found. If you hike the Walter F. Mondale River Trail, you get beautiful views of the St. Croix River and the valley left behind from when the river was bigger. If you tackle the stairs on the Sandstone Bluffs Trail or take the railroad trail, you'll see examples of the sandstone that was made at the bottom of a sea that was once here. And if you want to explore with an interpretive naturalist at the state park, we have lots of opportunities for that as well. Our state park offers programs of all kinds. You can explore plants, birds, geology with us, but those guided glacial pothole tours are pretty frequent from May through about October, and they are free guided tours. So we invite you to come out and get your hands on the evidence left behind by these stories. And the full offering of our programs, especially the spring ones, will be posted next month if you want a little bit more information about that. And with that, I'd like to thank all of you for your time in exploring a billion years of history at Interstate State Park. And I'd also like to thank the Wild Rivers Conservancy for the opportunity to share these stories with all of you today. I've got my email address on there if you have questions about the park and its geology later. And the website that you can look at to find more information about our calendar of events is below as well. And at this point, I'm going to turn things over to the wonderful staff at Wild Rivers Conservancy. And if you have questions about the park and its geology, we've got a little bit of time to answer some of those. And I'll stop sharing my screen so you can pop on there.
All right. Thank you, Jenni, for such a wonderful presentation. I appreciate you taking us through time and understanding how our wonderful interstate park was shaped. I will pay greater attention to my surroundings and rock formations next time I'm on a hike. All right. So now we have about 15 minutes for questions. So please enter them into the chat box. I think that will be the easiest for us to navigate. As I give a little chance for some of those to populate, I'd like to give a special thanks to Jenni and her volunteering her time to speak with us today. Oops. All right. Taking a look here. We have one referencing one of your early slides, Jenni, where you showed the distribution of, I believe it's the basalt rock throughout the Midwest.
Yes.
We have somebody asking what the red marking to the upper end was. I believe it was almost in Canada.
You know, I don't know the answer to that. That was a USGS map, and I'll have to look up and see what that mark up there was.
I personally have a couple that I can ask you really quick.
Yeah.
How do they go about estimating? I think the 123 Lake Superior's worth of lava fact really stuck with me. How does somebody studying our geology and history of the area go about calculating that?
Well, they have a few different ways that they can try and calculate that. We saw that gravity map that kind of gives you an idea of where some of the basalt rock goes. But then there are geologists that are starting to use seismometers. So they're basically using the movement that's happening to sort of get an idea of what's happening beneath the Earth's surface. And because that basalt rock is so dense and heavy, much more so than a lot of the newer sedimentary rock that might be covering it in a lot of these places in the Midwest, that helps them sort of put together a little bit of a slightly more 3D picture of the extent of those lava flows, the basalt rock. So when we're talking about those lava flows extending down into Iowa and into Kansas, or even part of, southern Minnesota, we can't see the basalt rock in those places. It's covered by layers of newer rock, but they're getting their information using the seismometers, kind of taking readings about the density of what's below them in those areas, and then sort of painting a picture with that. And their geologists are continuing to do more research and studies with that technology. And technology has really grown and changed quite a bit in the decades that people have been studying this. So I'm excited to maybe hear what new things they find out about this mid-continent rift. I'm sure there'll be more information to add later too.
That is a fact I will take with me to my next dinner party and wow.
There you go.
Wow, all the guests. For families or individuals coming to Interstate Park for the first time, what are some things that they should come prepared with or expect? I know this theme is geology, and we touched on the changes, but the verticality and hiking difficulty, I think, would be good for newcomers to know about.
Yes, definitely. If you come to the park, one of the things that I love about it is it has so many options for kind of the length of trails. One of the things that's sometimes challenging at the park is that rocky terrain, we talked about why it formed, but that rocky terrain really is found on almost all of the trails. So when people come out to the park, we recommend that they wear shoes that have good traction on them when they're out there so they can be comfortable and feel stable as they're out exploring the trails. The Walter Mondale River Trail is sort of a rocky up and down trail, so you have to be okay doing a little up and downhill walking. If you want to see the Sandstone Bluffs Trail, kind of down by the park office, that one has over 400 wooden stairs on it. So it's a kind of an intense landscape to explore. And so for that one, you would want to feel like 400 stairs was something that sounded fun to you. If you go into the glacial potholes area, which is the most popular area of the park, you can walk about 1/8 of a mile and be able to see some of those views that you saw on the slideshow earlier. The rock is going to be a little uneven in places, And there are some short sets of stairs out there. So again, you're going to want shoes that have good traction with them, but you can get out to that scenery pretty quickly. And then we just always recommend that people use caution. There's outlined trails in all of those areas, and those are the safe spot to enjoy the scenery from. So you can stick to those trails and really enjoy seeing some of the best features of the park.
Perfect. And as always, I'm sure they can contact the visitor center if they have
Yeah.
questions about conditions or best time
Yes,
to
and I
visit.
should say right now the parking lot by those glacial potholes is closed. That'll open up a little bit later this spring. So the facilities are kind of quiet at the park at this moment. And as our staff starts coming back to the site this spring, more of those facilities will start to be open. By May, that visitor center is usually open, at least on the weekends. And then the facilities start to open up. So there's a lot more available there as the spring season progresses.
Perfect. Let's see. Well, if I don't see any other questions coming in the chat here, my colleague Hannah has pasted in a couple links in the chat box. Please take a look. We have a link to our upcoming events where you will find the next 2 lunch and learns listed. We have birding surveys in the riverways coming up here in March, as well as a climate change and forestry focus led by our own staff member Alexis in April. So please check that link out to register. We encourage you to do that, as well as there is a 3-minute short survey to help us better shape upcoming programming and lunch and learns just like this in the coming seasons. And we appreciate everyone, and I'm very grateful for you dedicating your time today and sharing your knowledge with us, Jenni. That was very educational, and you made it very easy to follow us through a billion years in 60 minutes.
Excellent. Well, thank you so much for the opportunity and for your interest, everybody in the audience.
Thank you.
Have a great day, everybody.